Hey guys, George at SoundTraxx here. This week we're going to take a little dive into what it takes to upgrade a Tsunami 2 to a new Blunami. Now today we're actually going to use a factory installed Athearn GP38-2 that I have right here. Now this is a model I've actually already added things like class lights and truck lights and including illuminating the number boards. So today we're going to show you what it takes to upgrade a Tsunami 2 to give you the Blunami Bluetooth wireless control, and then we're going to take a few minutes and set it up and get everything matched up and do the lighting and everything like that and show you just how quick and easy it is in the app. So guys, we're going to go ahead and take this model to the workbench and let's go ahead and get started. Okay guys, now we're back here at the workbench, and one thing I do want to point out is have an organized workbench. Like I've got all my drills here, knives here, tweezers, brushes, things like that. So just try to organize. These are just inexpensive things you can get at the local Walmart or the Office Depot that are just little drawers. And it's good to have all your stuff where you need it so it's accessible. But you want to go ahead and get all your tools out so that you've got it. Now for this conversion, we're not really going to need that much. So what we've got here, X-Acto knife, I don't know if we're actually going to need it or not, but we have it. Tweezers to help us with wire, so we can hold the wire when we're doing the soldering. It's a whole lot better to heat up the tweezers than it is your fingers with a soldering iron. I've got a couple pieces of heat shrink tubing because, and we'll talk about this a little bit later, but we will be needing to add resistors, and so I've got a package of 1,000 ohm resistors, and of course a screwdriver that we need to pull the coupler boxes out so we can pull the decoder. Now, of course, we have our Blunami decoder right here. This is the Blunami PNP for EMD, and that'll have our 645 non-turbo sound. And then I've just got these little bins. A lot of times you can get these from from restaurants, leftover sauces or dips or whatever the case is. These things are cheap and they make great parts bins so that we can put our coupler boxes in there so that we don't lose them when we're working on them. So with that aside, I'm going to move some of this stuff out of the way, and we're going to start with just our regular screwdriver. Now here on the workbench, this is a hard surface, and with the hard surface you want to make sure to protect the details on your model. And so what I've done is I've put some layers of just the box foam that you see that you get in the model boxes, and then you can get some other thicker stuff, and this allows you a little bit of a workspace. You can get other things. There's like engine cradles, stuff like that out in the market that you can find. I don't really find that they're that necessary. So first thing what we're going to do is we're going to go ahead and we're going to remove these screws for the coupler. So you can see the coupler box screws are right here. And this is what it's going to take to get our coupler box out. So we have our screw, we'll put it in our bin, and then we can just push the coupler box out. And as you can see, I've upgraded this coupler box with a KD scale knuckle coupler and glued that box together to help protect it and keep it easy to work with. And then we're going to do the same thing here on the rear. So we got our screw out, and then we can just use our, now this one apparently I didn't glue together, or the glue came undone, whichever the case, but we've got our coupler box with our KD coupler knuckle, our KD knuckle coupler, and we'll just go ahead and snap those together, and then we can put that in the parts bin. Now the good thing is about this model, that's all it takes to hold the body shell on. So what we're going to do is just gently lift up on each end and free up the shell. Handling is another thing. That's always a challenge. So we're going to go ahead and lift up on the shell, and this should come right off. Not sure why it's not coming off. Probably because we're on camera. There it goes. Just a tight fit. Very tight fit, apparently. There we go. So now we have our body shell off, and you can see that I've already upgraded this particular model to to have all the extra lights and so forth. So that's what all these wires are. Now, if you look inside here, wire management is a big thing. And so you want to make sure that you have your wires going where they're supposed to. And so what I'll do is a lot of times I'll take these small pieces of, you can use our heat shrink tubing. You can cut them off into small pieces and glue them up on the inside of the body shell so that way you can run your wires through there, and that way it keeps it up off the mechanism but also keeps it organized. And depending on how you wire it, I mean, in this case you can see 4 pieces here. And so I've got the wires divided up. So I've got headlight, number boards, front class lights, and truck lights. So that way it's easy to go back in and diagnose if I do run into any issues. So when we look at this particular decoder, what we want to do is we want to separate the lights and wires as we need. So a lot of these, for example, the speaker wire is right here. Now, some of this hasn't been changed, and so these still have the little black plastic retainer clips that hold them on. So these are your speaker plus and minus, and then your motor plus and minus right here along the side. Now, on this original decoder in this Blunami 2, everything's labeled, so it should be easy to identify. And so we're just simply going to slide off these black plastic retainer clips, and we're not going to reuse them. We're actually going to solder to the actual board itself. So we can just remove those and just pay attention to where your wires are coming from and where they're going. Because especially in this case where we've got a lot of wires already added, we're going to want to make sure that we pay attention to which wires are going where. So same thing here with our motor plus and our motor minus. We're going to pull these retainer clips off. And you can see these retainer clips right here. They just slide right off. These are used in the factory because they don't want their factory assembly people dealing with soldering irons. And so they wrap their wire around these tabs and slide these over it. It works okay. It's fine. But I highly recommend replacing these and resoldering them, especially if you're doing a conversion to move it to a different type of decoder, or if you're going in and adding any wires. Like you'll notice all of these wires here where I've added the lights for the F3, F4, F5, F6. All of those wires are soldered. And so we're going to do that when we install our Blunami 2, our Blunami. So now on this particular case, we can pull this tab out slightly or push the tab in, and the decoder will come free. Now this is where we can remove some of the last wires, such as the track wires, which are right here, front and rear. So we'll pull these retainers off, and you want to make sure that you know which wires are going where. And so you can pay attention and kind of put them here where you want them so that they're easy to remember which way they're going. One of the things I've done a lot of times is I'll take these self-closing tweezers, and you can grip wires together that are supposed to come together and just hold them in place so they're out of the way, but also so that, whoops, I grabbed the speaker wire. I want the track wire. So this is the track wire here. This is the other track wire. This is why it's important to pay attention to what you're doing, is you want to make sure that you have the right wires together. And then we're going to do the same thing here on the other side. We're going to remove the right rear track retainer clip here. And then this should free our decoder up. So now you can see our decoder is completely free of the body shell. So we can put it over here and rest it on top out of the way. So we have our wires over here. Now let's grab another set of self-closing tweezers to keep those together. We have our speaker wires here, and then we have our motor leads. So now we have a bare chassis that's ready to install a decoder, and then with these wires already being here, we can take these off one at a time and attach them to the Blunami decoder. So now we have our Blunami decoder. Now, for those of you guys who have never used a Blunami decoder before, I'm going to show you a couple of things here. First off, let's open the package up here. And you're going to remove these staples. There's 2 staples, one on each side of the packaging. I know they make a tool for this, but I don't have it here by my workbench, so we're going to use a flathead screwdriver. Now, when you get your Blunami package, your decoder is going to come out. It's in a sealed bag. You can set that aside, but I encourage you to take a look here at the information document that comes with the decoder. And the reason for this is there's a lot of great things talking about installation, wiring, lighting outputs, things like that, speaker tips, especially with this Blunami PNP. These are 2-watt amplifiers, and so if your speakers are not capable of handling the 2 watts of power, you want to revisit or reinvent how you've got the speakers in there, because you can easily blow out the speakers if you put too much power to the speaker. So you want speakers that handle higher wattage, higher power than what the decoder puts out. Now in this case, we have 2 cube speakers which are wired in series, and those are capable of handling the 2 watts. However, as you'll see here in the setup video, I usually tend to set my volumes way down, so there's nowhere near 2 watts being pumped through those speakers. But anyway, you want to take a look here. Here's a wiring diagram, and you'll notice that each of these lighting outputs does have a resistor that is necessary for work with LEDs. And there's a note here: this wiring diagram assumes the decoder will be operating using LEDs. For more lighting options, 1.5 volts or 12 volts, visit our manual section of the website so that you can get the proper wiring diagram for your model. In this case, these are all LEDs, and we do require a resistor. Now, the really big question about resistors with LEDs: why do we have decoders that are not LED friendly? Well, the first reason is because everybody has a different perspective of what good light looks like. In years past, we've had friends of the company come over and say, "Man, look at how bright those LEDs are. They're fantastic." And at the same time, we've had other friends of the company come over and say, "Oh my God, those LEDs are too bright." Now, we do have a CV for brilliance adjustment, which is a master brilliance, which adjusts the brilliance of all of these lights together. However, the issue is that not everybody's happy with the highest brilliance, especially if we pre-do the resistors. Now, this particular board for Athearn is pre-regulated for LEDs, but what we did is we sent them several different samples with different varying brilliances and had them pick the one that they liked. And so this board is designed to match the brilliance that Athearn has requested. Now, that's why we don't include resistors in, say, for example, the Blunami here with the BLU-PNP, because this allows you as the modeler to pick the brilliance that you like. Personally, I tend to go a little bit on the dimmer side. Especially modeling 1978, we just barely invented halogen light bulbs, and so we really were starting to really get the first real brilliance. But we as a society tend to look at in the past with today's eyes, where you see a modern BNSF ES44 coming down the track with really, really bright lights, and that just isn't the case. So we have this ability to adjust it. But if we put a resistors on the board, inevitably people are going to say that's too dim. And now the only way they can brighten it up is if they bypass the controls or the LED regulators that are built onto the circuit board. And so that's one of the reasons why we do not include LED resistors already on the circuit board, is this allows you as the modeler the control to be able to pick the brilliance that you like. So with that, we're going to go ahead and one other thing I did want to mention is right here you have a default list of function assignments. Now, as we know in the Blunami app, this is all labeled out, but if you do use it with a DCC system, which you can, here's your function assignments. And then you have some basic CVs and some sound effects. And one thing I want to point out, this is a small sample of the air horns that are pre-programmed in. There's 44 different air horns programmed in. You've got up to 9 different diesel prime movers, which are set up right here. And then you have some basic common CVs. This is by no stretch of the imagination a comprehensive look at the operation of the decoder. So you will want to go to the user's guide and really read that. And then just some basics, bullet points and things like that on the back. But I do encourage you to open it up and check out the wiring diagram and verify to make sure your wiring is going to match what you're doing in here. So with that, I'm going to go ahead and get my soldering station ready. I'm going to wet the sponge, turn on the soldering, and get the soldering tools out. I will be right back. Okay, so now I got my soldering station up. I've wet the sponge here so I can clean off the soldering tip of my soldering iron. One other thing you want to make sure is you have a proper flux. Now, I can't stress this enough. You want to make sure that you have a flux that's designed for work on microelectronics. Now, in this particular case, this is a ChipQuick CHIPQUIK SMD 291. It's a no clean tack flux, and this is designed for work on microelectronics. And so you see it comes in this syringe. Now, this was a full tube when I got it like 2.5 years ago or so, maybe 3 years ago. So you have plenty of flux in here to do the work you need to do. And the advantage to the syringe is you can control exactly how much you're going to use on each of the connections. So we're going to be using that throughout the course of this installation. Now we have our Blunami decoder here. We're going to go ahead and cut the package open. Get the decoder out. Now in this particular case, as you can see, the decoder sits here on top. So we can start either pre-applying these, or we can just mount it up and mount the decoder. Now on the bottom of this decoder here is where you have all the labeling for the packaging. And so you want to have that ready and kind of have an idea of where everything's at. The other thing is, again, you have your wiring diagram nearby. So it'll tell you where everything is as you put it and orient it to the decoder and the model. So we'll go ahead and set this in. Now our M plus is towards the front. So what we can do is we can actually take these motor leads and put them into the respective holes before we mount the decoder down, so that these terminals come up through the underside and are tucked safely away, so we don't have to deal with them interfering with anything else. So put our motor terminal, our motor wire through here first, and then we're going to do the same thing with our negative lead. So now that slides right up in there, and this one slides right up in there. Now what you can do is you can take these and bend them so that the wires kind of go all over the flat part of the connection. But we can solder these right now. So what we can do is we can go ahead and take a little bit of our flux, apply a little bit of flux to the joint. Now our solder, I just have a roll of it here, so you can pull this out. And then just use this to put just a little bit on the end of the iron. We got our flux, and we make our solder joint. And now we can trim the excess off of there. So we don't need all that extra wire. So we just trim the excess off for a nice clean joint. Now we're going to do the same thing here for the motor minus terminal. So again, I don't seem to be able to twist these wires today for whatever reason. Okay, so we've got that through. Put a little bit of flux on the joint. And again, you don't need much flux. Remember, it's just to help the solder flow onto the joint a little bit better. So we're going to come in here and we're just going to touch it. And there we go, and then we're done. So now we can trim the excess off. And just like that, our motor terminals are connected. Now, because they are located under the decoder here, we can go ahead and mount this decoder in place if we so choose. So I seem to have noticed a issue in the location of these tabs. They're off by just a little bit, mounting in comparison to where these Athearn tabs are. So, in order to make this work and fit in the space, because we have our speaker wires here, and in order to make this work, what we're going to do is we're actually going to trim these tabs off. So, where'd my cutters go? So we can cut these tabs off here, and now what we can do is take some double stick foam tape like I have here, cut a small piece that will mount down right in here, and it looks like we may need a couple of pieces to get up to the height of where this is, and then we can just mount that down. So I'm going to go ahead and do that off camera, and I'll be right back. Okay, so now that we have our decoder mounted, now we have our track wires that are coming out on each side. We have our right and left track wires. Now what we can do, now on the factory decoder, these front two terminals on the decoder for the FX7 and 8, so the track powers were all connected to these back terminals. So we have this really long wire. Now you can mount it right there and just move on with your life, or you can separate them and attach one to the front, one to the back. Ultimately, it doesn't matter which way you do it. But what I am going to do is I'm going to shorten these wires a little bit, because I don't need quite as much wire coming in. And then you're going to get your wire strippers, clean them off from last time, and have a little bit more extra wire there. Now again, I'm going to mount this coming up from underneath just to minimize the amount of wires on top, and you can do the same thing. We're going to put a little bit of flux on the joint, grab our soldering iron, and that is soldered in place. So I'm going to go ahead and do this on these other 4 wires. I'm going to go ahead and shorten these leads and put them to the front track terminals, and then the back ones are going to go to the back track terminals, and I'll be back in just a few moments. Okay, so now I've got all my track wires soldered to the circuit board, and I took the front wires and attached them to the front, and the rear wires and attached them to the rear. And like I said, it's really not important as far as whether you put them both on the rear terminals or the front terminals. 6 of one, a dozen of the other. Do whatever makes you feel comfortable. Now, next up, we have our 2 wires for our speaker. Now, these are the 2 wires here. Now, we're going to put those to the speaker terminals. So now when I look at the wiring diagram, the speaker terminals are these 2 over here. So they're next to the current keeper plug, which is right here on the side. And we're going to solder these 2 wires to the terminals. Now, speaker plus, speaker minus really doesn't make that big of a difference at all, especially when you're doing one speaker for what we're doing. But since these speakers are already wired in series, again, it won't matter which is positive, which is negative. We already know the speakers are going to work together in tandem. So what I'm going to do here is I'm going to pre-tin the wires, and there's a lot of excess stripped wire here on the end of this, so we're going to go ahead and trim that down a little bit. Now if I can get my tweezers to hold these wires so I can just zap them really quickly with the soldering iron and pre-tin the ends. So we're going to go ahead and touch that here, and let's grab a little bit extra for the other wire. Alrighty. Now, as we know, we're not going to need this much, so we can trim these a little short, because we already know this is going to be way too much wire. So I'm going to get our flux, put a little bit here on the pads, and since this is red and black, we've got positive and minus. Speaker plus is the one next to the current keeper. Like I said, ultimately it doesn't matter, but for this installation, we'll go ahead and follow that rule. So we'll go ahead and get a little bit of solder on the end of the iron. And then, normally I do this with the tweezers. So, There we go. We got one in. And then now we have the other one in. Now at this point we can test the decoder. Since we don't have any of the lights attached to it, we do have a separate model. We have our track power leads, we have our speaker, and the motor wires hooked up. There's absolutely no reason why we couldn't test it as it sits right now. Take it for a test run, run it back and forth, just to make sure everything's good. I'm not necessarily going to do that today on this installation. So what I'm going to do is I'm going to tuck these speaker wires back up into the tape here. Obviously the easiest way to do that would be to have pulled the tape up, wrap the wires back under it, and do it again. And what I'm going to do is I'm going to take my tweezers, wrap it around here. I'm going to twist it a couple of different times, take up some of the slack, and then we're just going to tuck that right there. And then we have our wires going to the speaker. And then what I'm going to do is I'm going to grab my Kapton tape, and we're just going to put a little piece over that to replace the one I took off. Now we're going to use our knife. We're just going to cut the tape, put that over the top here to hold those speaker wires in place, just so they're out of the way and not floating around loose like rebels. Okay, so now you can see we have a nice tight clean installation. We've got our speaker wires tucked in, we have our track power leads tucked in, and they're safely out of the way. So we could, like I said, we could take this for a test run now. We're not going to do that. We're going to go ahead and go for the installation. Now on this particular installation, when I did all of the lights, I have function common wires. So I have a function common here, a function common here, and there's actually another function common here on the side. Now when I come to the Blunami, there's only the two function commons. You have one on the front and one on the rear. So what I'm going to do is I'm going to take these two towards the back, combine them together and attach it to this function common, and then we're going to take the others and attach it to this function common up here. Then what we're going to do is we're going to take each function output wired one at a time and attach it to the various terminals here along the side. But in doing that, we're going to add the resistors as I talked about earlier. So I don't need this anymore, so tidiness is key. Okay, so now what we're going to do is we're going to start removing some of these wires. Now we're going to do this one at a time. So with a hot soldering iron, you don't want to rest the decoder on the foam, because if the foam gets hot and melts, then it kind of defeats the point. So I just grabbed a small piece of scrap wood from the workbench out in the garage to set the decoder on and use it as leverage while I desolder from the circuit board. So first off, we're going to take off these function commons. Now because these are all tied together, we should be able to just simply hit it with the soldering iron and pull them out as a collective group just like that. And that's how I've done on these other ones as well. So let's go ahead and move this over, and we're going to grab these wires like this, apply our soldering iron, desolder, and these come right up. And then we're going to do the same thing for this third function common over here. I gotta get my fingers cooperated and coordinated enough to be able to get to here. Heat that up and just pull that right out. So there's our function commons. Now when you're working on this and doing this, it's going to become a little tight because some of the wires don't have that much travel. So we kind of have to manage our space a little bit. So for starters, I'm going to pull these wires around a little bit so that they're kind of separated. And where is my... Alright, so I got my two function commons for the rear, which will go right here, and then the function common for the front. And again, we want to hit our tab with some flux. And so we'll start with this front one. Just like that. And we're going to do the rear the same way. So I'll be right back. Okay, I got that one in. Now, one of the challenges when you're doing these like this is, of course, wire management. We want to make sure that the wires are clean. And the other thing is when you're doing your soldering, you want to make sure that your soldering iron is not right up against any other wires. For example, these speaker wires. If you think these are going to be in the way, wait until later to make that connection. But getting this function common here towards the rear, I have these two speaker wires and I have a few components here, so my soldering iron has to come in at a unique angle, and that's honestly why I didn't do it on camera. Was I wasn't sure how the angle was going to match. So anyway, what I'm going to do now is I'm actually going to move this around a little bit, move it a little closer to me, and I'm going to take that foam and put the body up on top of this. Then this gives me a little bit more flexibility when it comes to desoldering. Now I have my front and rear headlight. These are going to be fairly common or fairly straightforward, but I'm going to show you how I'm going to attach these. So first, we're going to desolder them off of the board. Now, as you know, as you can see, I don't have a whole lot of room to be able to reach this, and a lot of that is because I've got these wires attached to the inside top of the body shell. So they're designed not to have a whole lot of flexibility, but I can move it over if I need to work on the model. So things are a little tight, but we can manage. So what I'm going to do is I'm going to rest the decoder. You can do something like this. And what I'm going to do is I'm just going to grab this front headlight wire. We're going to pull that out. Okay. Now we're going to set the decoder aside because we know we're not going to need it for the next step. Now, what I'm going to do is I've got to attach a resistor. Now, for my headlights, I like to use a 1000 ohm resistor. And you can get a 1000 ohm resistor fairly small. But what we need to do is we need to put some heat shrink tubing over it. And so you want to make sure that you get some heat shrink tubing so that you can protect that solder joint. So what we're going to do here is we're going to get a small piece of heat shrink tubing, cut it off, and then we're just going to slide that over the wire, just like that. And then what I'm going to do is I'm going to solder the wire to the resistor. And to do that, I've got my flux on the end of the resistor, and I'm going to hold the resistor with my tweezers. My wire's right here, so we're going to get a little bit of solder on the end. And again, you want to make sure, because I've got my body shell here, so I can't let rest the iron on the body shell or that could become catastrophic. So we have to make sure we pay attention to where the soldering iron is at all times. So now I'm just going to line this up next to it. I've got my flux. And there's my solder joint. And you can see that my solder joint has been made. So now I reach into the model and grab my heat shrink tubing. I'm going to slide it over the resistor. Now this is an 1/8 watt resistor. You don't have to use an 1/8 watt. If you have a 1/4 watt, an 1/8 watt, you just want to have something that's able to handle. These resistors are not going to get that hot, quite frankly. So you can use smaller resistors, but use what you have conveniently available. Personally, I like the smaller ones because they tend to take up a lot less space on the circuit board when I'm doing this installation. So now what I can do is I can do a couple of different ways to shrink the tubing. One, as we've showed you in the past, you can use the barrel of the soldering iron. When you get up on it, the heat will actually cause this tubing to shrink a little bit, and that's usually enough. So now when I look at this, you can kind of see it. Let's put this behind it so you can see. You can see how the tubing has shrunk down. That's just enough to grab the resistor to help hold it and protect the insulation. You can use other heat sources such as a heat gun or something like that. Sometimes I have been known to use a lighter, but again, you have to be careful because the flame, if you get too close, can actually scald the insulation off the wire. So again, you want to be careful. Make sure you have the proper wire source. Now, what I did here was, and I'll put this here so you can see it better, is I just bent the angle of the resistor lead down, and then what I'm going to do is I'm actually going to cut it so that it will sit flush here. So now on our headlight wire, I'm going to solder the lead, or put the solder on the joint, and I'm going to put my resistor lead into the hole, grab my soldering iron, get a little bit of solder on here, and let's see here, then we're going to make our connection just like this. And there you go. Now I'm going to do this for the headlight, the backup light, and then all the other lights that I added. Now on this model, all it came with was a headlight and backup light. Now all these other lights I've added, which is actually why they're all soldered in. So on the FX3, I have my front class lights. The FX4, I have my rear class lights. FX5 are my front number boards, and FX6 is the truck lights that I've added down here. So you can just simply desolder, work your way through one at a time. Now on these other ones, the FX3, 4, 5, and 6, now these are lights that would not be as bright as the headlight. And so intentionally, I'm going to use actually a 3.3K resistor. It's again, these resistor values, this 1000 ohm here and a 3.3K for the class lights, number boards, things like that, they're higher than what's necessary. But the good news is, as I mentioned, LEDs are more current sensitive, and so they're less susceptible to drastic changes in the track voltage, and especially if you're using a higher value resistor. I have a couple of models that I've actually used a 7500 ohm resistor because the older models, 1860s, would not have a headlight as bright as, say, a sealed beam on a modern day diesel. And so I wanted to knock the brilliance of that light down. So this is again an illustration of why we don't have the resistors on the decoder for LEDs. And so by simply doing this little step, you know, if you're doing just an OEM conversion with a headlight and backup light, maybe a couple of ditch lights, just grab you some 1K resistors. You can usually pick them up at the electronics store fairly cheap. They're about a penny or two a piece. But doing this one at a time, that way you have better control over the brilliance of the light. So if you're the guy that says, man, I love how bright those are, use a 560 ohm resistor. If you're another guy that says, man, those are way too bright, use a 1000 ohm or a 3.3K or even a 5000 ohm resistor, because now you have a little bit better control. Then when you go in and adjust your lighting effects, your master brilliance can be adjusted, but you've already taken the edge off of the really, really bright LEDs. And with these 3.3K on some of these other lights, you actually get a little bit better control down to the lower brilliances, so you get a more realistic effect. So I'm going to work through this. I'm going to get these other 5 lighting effects moved over. The backup light, FX3, 4, 5, and 6, and then we'll come back and put the button on it. Okay, I've got everything buttoned up. I've got all my wires connected, and I've got all my resistors attached for all of my different lights. Now is where you would think about putting in a stay alive capacitor or a current keeper, something along those lines. You guys have seen me make these little battery packs, or so to speak, before, just using 2 of our 220 microfarad capacitors wired in parallel. And then you can take a current keeper connector that you can buy on our website or at your retailer and attach the wires directly to there and plug it into the side and then put the shell back on it. So since I've done this before, if you haven't seen this, go back into our archives on our YouTube channel and search for SoundTraxx and Stay Alive, and you'll see a couple of different ways I've done these so that they'll fit in different spaces where we take multiples of these. Now with the Blunami, I will say I highly encourage using a current keeper or Stay Alive of some form. The reason is that if your decoder loses power, even for an instant, when it comes back on, what happens is a lot of times the Bluetooth connection is severed. And so it takes a few moments to reconnect to the Bluetooth module to then continue on and rerun and start running your locomotive. Whereas with a DCC system, if it loses power, it comes right back on, the DCC signal's sent, and it goes back out. But when you're using the Bluetooth wireless connection for your Blunami, power losses can become a little bit more catastrophic, and so you want to add things like stay alive modules or extra capacitors just as an insurance policy. Now in these models, typically as long as you clean your wheels pretty regularly and keep things running and keep your maintenance up, shouldn't ever have any issues. But it's not a bad idea to have that extra insurance policy built in, because like I said, if you lose track power, then your Bluetooth connection is severed, and it takes a little longer to connect. So I'm going to go ahead and solder this up just like I've done in the past. I'm going to plug it in here on the side, and then what I'm going to do is I'm going to use some Kapton tape and kind of tape the decoder down here, and then also tape this back here, and then I'll put the body shell on, and then we'll take it out to the layout, take it for a test run, and then we'll do a quick short little video showing how we select the sounds and so forth to make sure that our decoder matches the model that we've installed it in. So with that, I'll be right back, and you'll see us out in the layout. Okay guys, now we're out here at the layout. Now as you can see, my locomotive is on the track and powered up. And on the screen here, you can see that I have my Blunami V1.0 on the home screen, in addition to the other Blunamis that I have already on my layout, including my 2 GP15s that you've seen in prior videos. And I also did a GP38-2 number 2117, which was another Athearn Genesis GP38-2. So right now I'm connected to this Blunami V1.0. So I'm going to go ahead and go to my standard, and you can see that I have instant control. So the first thing I want to do is let's just test it to make sure. So we're in forward, so we're going to move in forward direction. You can see that our locomotive moves. We're going to move in reverse. You can see that we have control. Going forward, we make sure our lights work. We've got our headlight on, and we change direction. We have our backup light on. Now we're going to pull out our little side menu, and we're going to go to our FX3. So we turn the FX3 on. You'll see that our class lights are on. FX4, our rear class lights are on. FX5 is our number boards, and they're illuminated. And FX6 is our truck lights, and they're illuminated. So all the lights work, our motion works. So now we just need to set up the locomotive. Now, if any of you guys have watched in the past, we have a video that I've done a full setup for my GP15s going through the process that you're about to see. Now, in the essence of time, because we've done the install, this is going to be really quick just to show you a couple of real quick things. So first off, we're going to go ahead and go to my settings menu. Now, the first thing we want to do is let's rename this so that way we can know which locomotive we're talking to. And so I'm going to call this the Mopac GP38-2 number 2031. And I'm going to save that, and then now our DCC address is actually 2031 because that's the locomotive number. We're going to press apply, and you'll see that the app has already connected it as an extended address. Now it's actually running from here. Now, as I've mentioned, the first things I do is usually turn the volume down. So master volume here you see is set to 192. I'm actually going to set this down to 100. And up in the top of the screen, you can see CV128 set to 100, and you can hear the volume drop significantly. We can even adjust this a little further. I'm going to go ahead and hit it as a value of 75. Now let's go to our sound settings, our main sounds. Now you see that our prime mover is a 567. We're going to go ahead and change that to a 645 non-turbo. You instantly hear that change. And then we're going to take the volume of that and set it down to 100. So again, we have lowered our volume significantly because in a small layout, typically you don't want to hear the locomotive on the other side of the layout, which is supposed to be miles away, as if you're standing next to it. So this is one of the things. Now pitch shift, I'm going to go ahead and crank that down a little bit. And what that does, it just shifts the sounds overall so they all sound a little bit different. Up here, we're going to get into the notch rate and stuff like that another time. Like I said, you can watch the GP15 videos. On the air horn, we're going to go over here. We're going to cycle through till we find this Leslie RS3L. Now we want to sample it. And you can hear it. Now that, again, is extremely loud. So I'm going to take this down to a value of 80. Now let's try it again. You can hear that it's still loud, but not excessively loud. So in our small little area here, the small layout that we're working on, you'll be able to hear it just fine. And as you can see, we can work through, do a lot of these other things. Usually my bell I turn down to about a value of 40 for volume. And again, you can hear it. That may even be able to be adjusted down to like 30. There we go. So now we're kind of in that range where I can hear it when I'm right up on it, but not when I'm halfway across the layout. So this is just a really quick setup and just kind of show you all the different settings and everything. When we go into lights, just to show you the FX3. Whoop, let's shut off our bell. Now let's just show you really quickly. Let's take our class lights, for example. We want to tone those down as an on-off constant dim. So our lighting effect, you can see we're going to cycle through the menu here till we find on-off brightness 1. And you'll notice that they've already changed a little bit. We're going to change it from an incandescent to an LED. And now when I go over here to my brightness 1 setting right there, I can change this. And we're going to go ahead and take that down to a value of about 50. And just see what it looks like. Now that's actually a really good brilliance because you don't want it as bright as the headlight. And then we can do the same thing with the rear class lights, which again are the same settings. Change that to an LED, and that again, like I said, that's a nice brilliance. Now for the number boards on FX5, we can try it. We can go ahead and certainly set it to the same on-off brightness 1, which you may think that's a little dim. I think it is a little dim, so we're going to go ahead and make this on-off brightness 2, so that it's a little bit brighter, and we can adjust the brilliance independently. When we go up here to brightness, we have our brightness 2, and this is where I can adjust this up or down. And there's a value of 75, and you can see that it's a little dim, but not really bad. Then we can go back down to the FX6, and again, this is our truck lights down here. So we're going to change that again to an on-off brightness. Let's try 1 first and see what it looks like. That might be a good brilliance. If you don't like that, we've got 2. So let's match it up to the number boards. It's a little brighter. I think we'll stick with that one. And again, we tell it it's an LED. and you're going to get a nice brilliance in there, and you can play with this and adjust it as you see fit. But these are just some of the settings that we have in our decoders in the Blunami that you can use to adjust. So now that we've upgraded this factory installed model, now we just get to go ahead and play. So now we get to go in and set up all our momentum rates and braking rates, things like that. And like I said, if you're not sure what those are, watch our installation and setup of the GP15s that I did just about a month or two ago, showing the installation of this and the setup that I did, because a lot of these settings that I'm going to be doing for this model are the exact same ones that I did for the GP15s. Of course, we'll change some reverb settings and equalizer settings so that they're all just a little bit different. So guys, I hope this has been helpful for you. If you have any questions, feel free to reach out to us at support@soundtraxx.com, and be sure to click that like and that like button down below, and be sure to subscribe to our channel so you can get lots of great information just like this anytime. And with the notification bells, you'll get direct notification to let you know when a new video is dropped. So guys, thanks for watching. We'll see you next time.